So here is two soldering iron stations. These are Duratool branded ones, which is CPC Farnell's own brand. Well, I say it's their own brand. I think sometimes they rebadge stuff. For instance, I think this one on the right is actually a Silverline one, or Silverline themselves rebadge it from someone else, who can say. The one on the left, they use the same base station with a few different connections on it for the hot air gun they do. So this one was pennies. Do you know, I don't even think I paid a tenner for it. It was on like offer. They send you a catalogue through once a month once you buy stuff off them, and it has offers in it. I think this was on offer. Bit back, this one was on offer. I think this was about 36 quid or something before VAT. Now, both of them are sold as a temperature controlled soldering station. This one sold at 48 watts. This one is 60 watts. Now, this one, if I hold it up to the camera, can you hear that? Two ways to stop it making that noise. Turn it off, or turn it all the way flat out. So the reason it makes that noise is because inside of this is just basically a glorified dimmer switch. Like, it's just a triac based you know, mains chopping adjustable power supply. It is not actually a temperature controlled iron. There is no temperature sensor in here. There is no circuitry on the board to sense temperature through resistance of the element or anything. When you twist this knob, you are literally just adjusting the power of the iron, and they have a scale on the front here, which I suppose is worked out. Whether it's worked out is that's the temperature it will get up to sat in static air, or with occasional soldering. It's hard to say, because with soldering iron you have thermal mass. So I took the time of plugging it into a, you know, one of those little plug-in power meters you get for plug sockets. Plug in amazingly. So I just took the time to put some, you know, what was going to be easily definable positions on the gauge, or useful power rating. So it's 0 all the way down. It's 8 watts. So you can see on here you've got the increments. So 0, it's 8 watts, 11, 13, 20, 25. So I marked off 25 because that's a useful kind of power setting. 25 watts being what your kind of standard Antec iron or your cheap thermally balanced soldering irons will run at. You can get more powerful ones for doing heavier joints, but you can't really leave them sat idle for too long because they get really hot if you're not using them. So that's 25 watts and 30 watts, two realistic power ratings that you're going to use on it for smaller and bigger stuff. And then I just took the liberty of going around the rest of the dial, 35, 40 watts. And then flat out I was actually measuring 47. Some loss will be occurring within the switching circuitry, but it's really not very much at all. It barely gets any heat in it. So anyway, reason I'm basically reviewing these is I'm going to put them side by side. Now, to start off with, I ordered some 2mm tips for this one. I'll get it in some better light in a minute. They've not turned up yet, so the best I've got is a 3mm chisel tip. Burn the hand here, and this one has a 2mm, oh man, that has gone so hot, wedge kind of tip, like dual-sided spade tip, whatever you want to call it. Now if you notice the settings, this one is set, well, all it says on the side here is 350 degrees, so it's somewhere in the 300 odd mark, and this one's got set at 345. Zoom in on that. So let me just reposition his camera and get some more light on the job. So I'm going to address thermal mass to start off with. So this is this is a spare iron I've got for the actual proper temperature controlled solder station. So if you take it apart, the actual heating element is this white bit. So the temperature sensor is in this white bit. Whatever temperature you set it at, it's measuring the temperature of the heating element, not the tip. So the tip is hollow, it's very light, weighs a couple of grams max, and the only way for the heat to transfer from that element, you can see it doesn't even tolerance fit round there, is through the air gap round the element, which is a very poor conductor of air, of heat, and the small amount of physical contact in the end of this tip. Well, this is flat. The inside of there is conical. It actually follows the shape of the tip, so there is very, very little thermal contact between that heating element and that tip. So it means when I set the temperature of the temperature controlled station, it'll get the element up rapidly to the temperature I've set it at. The element will sit at that temperature, and then the outer sheath and the tip will end up in a thermal balance between the amount of energy it can actually pull out of the tip, the element's going to keep turning on and off, and the air is going to convect some of the heat away from the tip of the iron. There's going to be some radiation through infrared, and you'll end up in a state of thermal equilibrium where the amount of heat being dissipated external parts of the iron exactly equates the amount of thermal energy being put in from the electrical supply. So it is handy because it means the iron isn't going to overheat, but it also means if you set it at a nice temperature for, say, soldering a couple of small joints, that if you then want to come in and solder, say, some big capacitors like this, all of a sudden you're going to find the heat's drawn away quickly from the tip of the iron. And to compensate that, if you crank the temperature right up, again, although the element inside is going to be held at a much higher temperature, the tip isn't going to get to that temperature because you're going to get you maxed out by its ability to conduct heat away from that element to the tip. And it might be perfect for soldering a few big caps, but then when you put it back in the holder, it's going to heat up and up and up. Admittedly, it will only get somewhere near as hot as you set the temperature control to, but it's not up there with, say, like, you know, your modern Wellers and your real expensive irons that are a couple of £100 that actually have the temperature sensing element in the tip, and that they are really good. You can set them at just above the point of the solder melting and pretty much solder with them. So that's the more expensive of the two's setup. Now the cheaper iron, although this isn't actually iron for it because that's hot and it would be silly trying to take it apart when it's red hot. It's a very similar setup. It is actually the exact same element is what this one takes, tip, sorry. So you've got what's quite a nice and chunky solid metal rod as the tip, and then a small amount protrudes. So it goes into the end of the iron, and rather than being like this one which is secured in with a screw, on this one this whole sheath is the element. This part here is the element. It's all wrapped around in there, and this basically is a small screw. This bit here unscrews and pull the element out, and this locks the element in place. So you've got a much higher surface area. You've got that entire length, well, of what this is, that's internal to here, to actually allow it to conduct heat in, and it's, you know, still there's a good air gap, but it's a much tighter fit. There's much less of an air gap. So it means two things. First of all, the energy you put into it is conducted more rapidly to the actual tip. But secondly, because it's a large chunk of metal, it has a good thermal mass. So it means you can set it at a temperature somewhere near where you want to solder your components at. And when you push it onto the solder and start melting the solder, that solder is going to try and suck a large amount of heat out rapidly. However, because it has a good thermal mass, it's going to take a while for the heat to be pulled out of it and to cool down. On the flip side of that, it also means then when it comes to warm up again, it takes a long time to warm up. So small thermal mass, quick warm up, cool down times. Large thermal mass, slow warm up, slow cool down times. Now, onto the temperature control aspect of it. Because the cheap blue one, that one there, isn't actually properly temperature controlled, to get it in the thermal balance of, so you need to set it at a temperature where it's going to melt solder happily, and, you know, everything is going to flow and you're going to get enough energy into your joint when you're soldering. However, when you put it back into the holder, because that element is still receiving the same amount of energy and you're no longer taking energy out of the tip, the only thing taking energy away is the air, and it's going to get hotter and hotter. And what it generally means is if you pick the iron up and try and use it, you get like your solder oxidizes quite quickly. So you can see, look, this tip's been sat in the holder the same amount of time, It's still shiny, it's still silver. So this one, it's gone a bit grey, a bit more metallic-y looking, but if I put a blob of solder on this, it's not the ultimate background, is it? No, I've not been playing with myself, that's what I clean my solder tips with. Yeah, high contrast black. So if I put a drop of solder on here, you can see how hot it is, and it's tried to ball. It's you know, it's not wetted the whole tip. You see it's very, very hot, and now you can see, look, it's changing colour, it's oxidizing rapidly. I really should find a better background for that. Yeah, you see it's oxidized, it's dirty. If I tried to solder with that now, it wouldn't work. I'd have to clean it off, and you know, you've got very finite time of getting your solder on and getting it onto your joint with that. You can't wet your tip. You know, if you've got a tricky joint that you might just want to reposition a resistor or something, it doesn't allow you to do that. You need to have your component you want to solder ready. That's a bit of a better background, isn't it? Whereas this one, because it's only going to get to the maximum temperature you've set it to, so you can see, although it is hot and it's smoking, the solder is happily flowed all the way around the tip. It's still shiny, it hasn't sort of got that anodized appearance about it yet. It's not got that skin on it. Give it long enough, it will, because obviously it's a metal which can oxidize, and it's being heated up, allowing it to oxidize. So now it's finally happening. So it will happen either way, but it's going to happen slower with a temperature controlled iron. And I can tell you right now that although they're both sat, it's somewhere similar in temperature. If I put my hand over this one, it's not a great deal of heat coming off of it. Put my hand over this one, yeah, it is belting off of that one. So yes, the joy of a thermally balanced iron. So let's give it something to solder. So I've got this, just a bit of a board out of an old amp. So I'll try a transistor, try one of those bigger resistors, and we'll try one of those capacitors. So I'll start with the proper temperature controlled iron. So let's, probably not the best angle, but if I put this onto one of the joints, flow a bit of solder on, I'm miles away from where I want to be. There's a tripod between me and this. So yeah, it flows, you know, it's melting solder. Yeah, it's more than happy. It's doing the job on them, which you'd expect. Let's try something a bit bigger, like this inductor. So where are we on the camera? The inductor's just here under the board. Let's try this end of the inductor. Yeah, solder's melted, it's flowed in, look. I can actually pull that solder around. Yeah, it's more than happy. Clean that off. So, and then we will try one of these capacitors. So like I said, this iron is actually running at a lower temperature than the other one. So try it on this joint. So you get a bit of solder on it, helps with heat transfer. So you can see I'm stalling a bit there, but it is with a bit of working. So yeah, I can get it to flow, but yeah, it is a bit under temperature at the minute. I wanted to solder these caps in, or desolder them, I'd have to crank the temperature up on it. That's just the joy of having an iron which has got the temperature sensor in the heating element rather than in the tip, and doesn't have particularly good conduction between the element and the tip. If I left it long enough, again, because I've soldered a few joints, although they would have took some heat out, they wouldn't have took a massive amount out of it. If I did leave it for a minute or two, it would have flowed a bit more. But as soon as the solder starts melting, it's a phase change. You're changing something from a solid to a liquid. It can absorb a huge amount of heat when it does that. So it will cool the iron down rapidly. So let's try the cheapo super duper Duratool iron. So already I'm going to have to clean the tip on this. So you can see it's gone all it'll focus. You see it's like gone all blued and oxidized. Again, that's because it isn't temperature controlled. It's just sitting in that holder. So yeah, just a wipe with some toilet paper and she's all nice and shiny again. So let's try a few transistors. It's very, very hot. I can actually feel the heat coming up on my finger. Oh yeah, I did that capacitor. It actually fell out then. It got enough heat in it. When I did the second joint, the capacitor fell out. Let's try that inductor. It was this one here. Get on the camera. It's here. So you can see it's absolutely slammed into that. And let's try this big capacitor joint. So pretty much the same situation, although it is doing a better job. It's allowing me, look, you can see I've actually got spread, quite a good chunk of spread. But if I keep trying to do this for long enough, so I'm going to try and spread, and you can see, look, I'm stalling out now. It's sucked the heat out of the iron, and now I'm just really slowly creeping along. I don't have that. Try and go back. So yeah, that is the problem with a non-temperature controlled iron. So if I set the ever iron to actually start melting that, as I go back and forward, it will just keep on that temperature, and then when I hang it up in the holder, it won't sit there and start trying to smoke and overheat and get red hot on me. So let's turn these off. So nice and quiet. And this one just turns off at the back. So my thoughts on these irons. Now I've had this one, I've been using it a lot for over a year. I've got solder all over the place now. I don't know why I'm trying to clean up whilst I'm talking, but just force of habit. So I've had this one over a year and it's had a lot of use, and it is a good iron. And for someone starting out, someone who just wants better than, you know, your standard one of your standard just thermally balanced irons. I mean, they are all right. They have their uses. I've got like 5 of them there in different power ratings. And so you want a proper solder station, I'd say go for it. Like I say, it was about a tenner or something. But yeah, you just have to watch. You just have to watch the temperature setting. And what I used to do if I was up in here, so you know, whenever you're building something, you'll have a bit where you're maybe only putting the odd transistor in here and there, putting some wires in. You know, it's the joy of building stuff, fixing stuff. You might be poking around for ages, think you've eventually seen something, so you want to unsolder or resolder something. So you're just hitting one joint quick with the iron, and the iron's going back in the holder for 5, 10, 15 minutes, whatever. So when I'm in that mode, I would generally set it for somewhere about there, sort of straight up, because that's between like 20 and 25 watts, and it's just a good temperature. It will still get plenty hot enough in that setting, and it'll do a joint or two. But if you want to start doing a couple of transistors, you know, say you've then decided you're going to change a few parts, you really need to up it to sort of 25 to 30, depending on whether they're thicker legged. You know, if they're just small TO92 transistors, 25 watts is fine. If it's a couple of capacitors and say 3 watt resistors, you set it at 30 watts, and again, because it's not temperature controlled and because it has such a high thermal mass, you'll actually find if you're about to solder a lot of stuff, you want to crank the power up on it and give it 5 minutes before you try and actually use it, because it takes time to catch up. And then again, once you finish using it and you're going back to probing around, or you're off to have a cup of tea or whatever, either knock it down to a lower setting so it's still ready. Or what I used to do, because it takes so long to warm up, even if you crank it flat out, and then you can guarantee if you crank it flat out, you're going to forget you've cranked it flat out and it's going to sit there and start glowing red. I used to, rather than turn it off, used to knock it down into just the yellow section. It's not even really warm enough to solder with down there, but it's, you know, it keeps it warm. So yeah, if you want to look at that, if you want to get one, that is about what your power ratings are. So 8, 11, 13, 20, 25, 30, 35, 40 and 47, which corresponds to ones on the dial there. This one I like this one, but I've only had it a week or so, and like I say, I'm still waiting for the 2mm tip, so that realistically is way too big for most of the stuff I'm going to use it for. Just going to keep that in there for maybe some bigger stuff. But yeah, so it works. It's certainly better. I had a 48-watt version of kind of this many years ago with a real crappy iron on it. Mate got one at the same time. We both ended up chucking them away because after time the tips you'd get wouldn't even fit on it. They'd foul on the heating element. You'd end up just with the thing sat flat out all the time, because anything more than a few small solder joints and it would just suck so much heat out of the tip it would never heat up again. It was frustrating, and you could actually do more soldering with a cheap 25-watt thermally balanced Antec XS iron. So anyway, yeah, I guess that's just my ramblings on some soldering irons and a review on this Duratool one. I shall put the model numbers for these in the description. And if you've took the time to actually watch it this far, I know I don't make the most professional videos, so you've certainly got some patience if you do. I'll just say thanks for watching, and as always, I hope you enjoyed the video, and catch you next time.